Hey everybody, welcome to AP Physics. This is your weekly greeting for March 16th through the 20th. You have two things to do this week. That's make a sound video and pass a checkpoint quiz. And all of the directions are on the bit.ly. But let's begin with the problem of the week. Get your notebook out. This one is about a dog growling. Did you know the size of the dog determines the sound of its growl? And for this, we'll be using the speed of sound at dog body temperature at about 350 meters per second. So copy that part down and let's get some of this information here. We've got two dogs, a Westie and a Doberman. They give us the mass and the frequency of their first, what's going to be called a formant. And I'll explain that shortly. So the sounds of the human vocal system result from the interplay of two different oscillations. We have the oscillation of our vocal cords and the standing wave resonances of the vocal tract. So a dog's vocalizations are based on similar principles, but the canine vocal tract is simpler than that. When a dog growls or howls, the shape of the vocal tract is essentially a tube closed at the larynx and open at the lips. So I try to draw this here. That's a dog. Or a duck. No, that's definitely a dog. And we'll be able to use this relationship. We've seen something similar to it before with N, and that was when N could be any integer. In this setup, we can only use odds because of the way the vocal tract works, and it's an open-closed tube here. So all dogs growl at this low pitch because the fundamental frequency of the vocal cords is quite low. But the growls of small dogs and big dogs differ because they have very different formants. So the frequency of the formant is determined by the length of the vocal tract. And the vocal tract length is a pretty good measure of the size of a dog. A larger dog has a longer vocal tract and a corresponding lower frequency formant, which sends an important auditory message to the other dogs. All right, so let's do one for each. We've got the length of the Westie and the length of the Doberman. And that is reasonable. I mean, the Doberman's at about 1/4 of a meter. That makes sense because of the mass, relative mass. Look at that. That's about, yeah, that matches right up. That's what we predicted given their relative masses. This is from the Knight textbook, one of my faves. And that's the problem of the week. Arrgh.